Hello everyone. Today the topic is critical section problem. To understand what critical section is, we have to consider n processes. The processes are like P0, P1, etc. to Pn-1. All these processes may be changing some common variables, updating the table, writing the file, etc. So now where do these processes do all these exchanges and updations and all? They do it in the segment of code called as critical section. So critical section is a place where a process is able to update a table, write to a table, etc. So now for each and every process there might be n number of critical sections, but only one process will be able to enter into the critical section. To understand the critical section much better, we'll take an example of producer-consumer problem. This producer-consumer, the concept itself says when a producer produces, the consumer is able to consume. If a producer doesn't produce, the consumer will not be able to consume anything. So now this is a general structure of the process PI. So when we do it, when the condition is true, it comes as entry section, then we have the critical section, and then the exit section. Now let us consider with the producer-consumer problem itself. When a producer wants to produce, he enters into the entry section. Once he gets into the entry section, the producer is supposed to lock the critical section. Once he locks into the critical section, he comes into the critical section where he does all his exchanging, producing, all those stuffs. So when he produces, there's a count variable in it where the count variable starts incrementing. So every time a producer produces, the count variable increments by 1. So once the producer finishes his production, he comes into the exit section. The exit section is a place where he unlocks the critical section. This unlocking is done just to ensure that the other processes are able to access the critical section in the future. So then he comes out from the loop. So this is the process of a producer. The consumer, now if he wants to enter into the critical section, he just checks the critical section whether it is empty, it is free to access. If it is free, then he enters into the entry section. When the consumer enters into the entry section, he locks the critical section, he gets into the critical section and he starts consuming the goods produced by the producer. Every time he starts consuming the goods, the count variable is being decremented by 1. So once he finished his consumption, he exits from the critical section. While exiting from the critical section, he ensures to unlock the critical section such that the other processes will be able to access the critical section. The remainder section here is a section where extra processes might be taking place. Okay. So a critical section problem has two solutions. One is the hardware solution. The hardware solution is called as a synchronization hardware, and the other one is called as a software solution. Software solution is a Peterson solution. We are not discussing the solutions over here, but a solution to the critical section problem must follow the three conditions here. One is mutual exclusion, then we have progress, and then we have bounded waiting. Mutual exclusion. Mutual exclusion is if suppose a process PI is executing in the critical section, it must ensure that no other processes can be executing in their critical sections. So it's just a mutual understanding between two processes. Second one is progress. If a process is not executing in the critical section, that is if the critical section is empty or it is free, then some other processes might want to access the critical section. Again, n number of processes will be wanting to access the critical section. Now, which process should access the critical section is decided by the operating system, and this decision, it cannot be postponed indefinitely. Third one is bounded waiting. In bounded waiting, let us consider there are two processes, process P1 and process P2. Now process P1 is accessing the critical section. Once process P1 has completed and it has exited from the critical section is empty. Now there is process P1 and process P2 again who wants to enter into the critical section. Suppose the operating system is allowing P1 process again to access the critical section. P2 process has been waiting for a time interval. So this thing should not happen again and again. That is only process P1 accessing the critical section and process P2 waiting for an indefinite amount of time. To avoid this, there is a bound or a limit being attached to every process. Let us say, for example, the bound or the limit given is 3 times. So a process P1 can enter into the critical section only 3 times. The 4th time when it wants to enter into the critical section, the operating system checks the limit. Since it has crossed the limit, P1 is not allowed to enter into the critical section, and the other process, that is P2, which was requesting to access the critical section, is being given the permission to access. So this is the critical section problem. So a solution must satisfy these 3 conditions: mutual exclusion, progress, and bounded waiting. Thank you.